Assalamualaikum and salam sejahtera. My name is Syahrul Anwar bin Sumirin. This is my group members Muhammad Solihin, Faiz, Saiful, Zulhani and Syamini. This video presentation is about cervical implant material. An implant is a cervical inserted foreign material to replace a biological missing structure, support damaged structure, or enhance an existing structure. Material selection is important so that implant will last longer and efficient. Material selection can naturally match the one for implantation within the physical body. This video is about an explanation of hip replacement.
Your hip consists of two main parts that fit together like a ball and socket: the femoral head at the top of the leg and the acetabulum in your pelvis. A total hip replacement is usually done when severe damage from arthritis or injury has made it difficult to perform daily activities. During the procedure, the femoral head and acetabulum are replaced with artificial components called prostheses. An artificial hip prosthesis consists of a cup called the acetabular component and a metal stem called the femoral component. Your surgeon will begin by making an incision overlying your hip, separating the muscles and ligaments to expose the joint capsule. After incising the capsule, your surgeon will dislocate the femoral head from the acetabulum. He or she will remove any damaged cartilage or bone in the acetabulum, reshape the acetabular socket, and secure the acetabular prosthesis in place using special cement or screws. Turning next to the femur, your surgeon will remove the femoral head, shape the remaining femur to fit the prosthetic stem, and secure the femoral component using cement or other techniques. Once both components are firmly in place, your surgeon will slide the prosthetic femoral head into its acetabular counterpart, test the movement of your new hip joint, and verify that it is properly positioned with an X-ray. Your surgeon will then close the joint capsule, repair the muscles, place a drain in your hip to remove excess fluid, and close the incision with stitches or staples.
These are the best 7 material that we choose for cervical implant, which is polyethylene, polymer, ceramic from glasses, titanium alloy, stainless steel, cast iron, and brass from metal and alloy.
Hello, my name is Muhammad Zuhilmi bin Abdul Latif, B0518200095. I will continue this slide with the justification of the material. Material we choose have 7 material, which is ceramic, metal, polymer, titanium alloy, stainless steel, polyethylene, and brass. It has properties of fracture and tensile strength, density, hardness, and compressive strength. For the ceramic, it has a low fracture and tensile strength, low density, excellent hardness, and high compressive strength. For the metal, it has a low fracture strength, low tensile strength, high density, low hardness, and high compressive strength. For the polymer, it has a low fracture and tensile strength, middle density, low hardness, and low compressive strength. For the titanium alloy, it has a high fracture and tensile strength, middle density, high hardness, excellent compressive strength. For the stainless steel, high fracture and tensile strength, high density, middle hardness, and middle compressive strength. For the polyethylene, it has a low fracture and low tensile strength. It also has a low density, low hardness, and low compressive strength. And lastly, for the brass, it has a middle fracture and tensile strength, excellent density, middle hardness, and middle compressive strength. Next, for the design requirement for the surgical implant. The function of the surgical implant is to give the toughness, strength, stability, and durability for the movable bone. The constraint is it must have a good stability, low friction forces, adequate strength, and acceptable wear rate. The objective of this surgical implant, it must have to maximize the strength, maximize the durability, and minimize the material weight. The choice of this material is the free variable. You must the choice of material, cross-sectional, and dimensional of design. After that, I would like to continue with scoring and screening. From the 7 material, which is ceramic, metal, polymer, titanium alloy, stainless steel, polyethylene, and brass, we we have searched the properties of the material, which is fracture toughness, tensile strength, density, hardness, and compressive strength. We search these properties using the EDU spec, which is can be downloaded in the laptop or PC. uh, we found that properties for the fracture toughness, for the example of ceramic, which is 1.5 until 1.7 megapascal meter. For the metal 0 to 20 megapascal meter, and for the polymer 1 till 2.5 megapascal meter. In this scoring and screening, we can roughly say that titanium alloy have the biggest properties, which is I think the best material that we can choose. And lastly, for the ranking, we have calculated the ranking from the scoring and screening, which is the formula is the properties divided by the highest properties and times by 10 for the rating. Okay, as you can see, the ceramic have a total 22.33 ranking, metal have a total of 23.24, polymer have the total of 2.45, titanium alloy have a 38.30, which is the highest total of this metal. Stainless steel has a 34.85. Polyethylene have a 2.01, and lastly the brass has 24.38. Based on the ranking above, the best acceptable material for surgical implant I think is a titanium alloy, which is have the biggest ranking of the other material. Titanium has a stronger and lighter in weight compared to others material. Titanium also has a large tensile and compressive strength under repeated load stresses, making titanium alloy capable of withstanding strain. Titanium also has a large resistance to loads, making this material the best and suitable for its application as an implant.
Assalamualaikum and hi, my name is Muhammad Saiful Paramlan. I will continue the presentation with metal and non-metal. Four main types of material apply in hip implant. In metal on metal, divide both the ball and socket component are made of metal. This metal implant has been used in total hip replacement surgeries and hip resurfacing procedure. For metal on polyethylene is one of the least desirable hip replacement device. Both metal and polyethylene are subject to wear particles, and the plastic and metal contaminants that will envelop your entire joint are a cause for concern. Ceramic on polyethylene is currently the most popular hip replacement material. Patients understand the risk of metal joint and shock bring to their long-term health and are moving away from the material. The advantage the ceramic on polyethylene carries in the lack of squeaking and less total failure compared to all the ceramic counterpart. Ceramic on ceramic not have any biological adverse effect on allergic response. For example, patients that had an all ceramic device implant had lower rate of revision surgery. Processing parameter. The first one is shape. The shape of the hip implant must be made according to the suitability of the user, and each component need to be measured due to the size of the person's hip. Material. The chosen process must be compatible with the material used. Part mass. The mass of the hip implant selected according to suitability and research that has been done. Surface smoothness. In the application of hip implant, the surface smoothness is important and required because smooth surface make the movement of the human joint work well. Tolerance. A tight tolerance is required for the safety hip implant due to its complex shape and strength of the product depending heavily on user. Inspection. The inspection is important part of the process to ensure the accuracy and safety of the hip implant. Machine and equipment. There are several ways to manufacture hip implant. Four techniques will be discussed. They are rapid prototyping (RP), computer numerical control (CNC), hybrid technique with CNC, high precision machine. These all of machines are important to make the good hip implant.
Now we'll be looking at the flowchart of surgical implant production using 3D printing. Actually, there are a lot of processes that can be used for surgical implant production, such as CNC machining, high precision machining, rapid prototyping, and 3D printing. But as 3D printing is the most commonly used production process, so we'll be looking at the flowchart for 3D printing. Basically, there are 8 main processes: CT protocol, patient's image acquisition and processing, implant design, design evaluation and dimensional validation, motion capture and virtual surgical planning, fabrication, recycling of unused material, and finally sterilization and packaging. So for the first step, image acquisition and CT protocol are the most vital process for the development of 3D printing because it essentially informs how the implant design process obtained. The common medical technique are magnetic resonance imaging, MRI scan, and computed tomography, CT scan. After acquiring patient's medical image, the file will be saved in DCOM format, which stands for Digital Imaging and Communication in Medicine. That is a standard format for CT scan. So during the design process, image segmentation carried out where the scanned 2D image, like the CT scan and MRI scan, they only shows 2D image. So the scanned 2D image need to be segmented in order to separate the required part from not relevant muscles and fats. So after that, 3D volumetric reconstruction carried out to generate 3D image representing that can later be used to create this 3D CAD model for implant design. Motion capture and virtual surgical planning is an online collaboration between the surgeon, orthopedic engineering professional, and biomedical design engineer. So the main focus is to study and manipulate the patient's body defect to find optimal solution to restore it. Then they will discuss and design the most specific procedure to the engineers and also discuss about the design evaluation and dimensional parameter for the implant. Once they come to a conclusion, then they will start to restructure the design process. So the peace of mind and comments from the surgeon, orthopedic professional and biomedical engineer will be used and are most required in designing this implant. So before starting fabrication process, design will be checked again by those surgeons and engineers to compare the design geometry with the patient's CT image. So if the CT image and the design actually fits together, then only they will proceed. If no, the design process will be conducted again. After that, the CAD file will be exported to STL format, which is used in 3D printer. During fabrication, the 3D printer will be set up based on the required parameters. The post-processing steps can be done after cleaning the implant, and such steps are sandblasting, polishing, and also heat treatment. There is also an advantage of this production of surgical implant using 3D printing, where the unbound material can be recycled after the fabrication process. So last but not least, sterilization has to be done to the implant before use to ensure the safety of the surgical implant. This is to ensure total elimination of all forms of microbial life, bacteria, viruses, and spores. Some of the sterilization techniques are dry heat, ionizing, radiation, steam, and ethylene oxide. And finally, after the sterilization, it's ready for packaging. That is the complete flowchart and a general flowchart of a surgical implant produced using 3D printer. Thank you.
Assalamualaikum. My name is Muhammad Solihin. Now I would like to share the effect of parameter, testing process, and quality control on the product performance. First is material properties. We have 5 material properties, that is fracture toughness, tensile strength, hardness, density, and compressive strength. These all material properties is very important because it can avoid from failure. Second is process parameter. We have 5 process parameter, that is material selection, tolerance, inspection, design, and R&D. Third is testing process. This part explain how the testing process begin to the tibia base plate, after that to the femoral. Fourth is a quality control. We have 5 quality control, that is specification for surface finish of knee replacement, endurance properties of tibial tray, fatigue testing of TKL femoral component, total knee replacement loading profile, tibial insert endurance and performance under high flexion, guide for evaluation of modular hip and knee implant. After that, we have defect of implantation surgery. In this part, we have infection, nerves damage, bone fracture, persistent, increased fall risk, deep vein thrombosis, stiffness, prosthesis related complication, and high risk activities that may not permitted. And lastly, we have countermeasure. We have three countermeasure, that is achieving a minimum 110-degree active knee flexion and full knee extension, achieving ambulation goal, and lastly is achieving compliance and competency with a home exercise program.
Manufacturing process. Hip implant surgery consists of 4 types of process, which is rapid prototyping, computer numerical control, hybrid technique with CNC, and high precision machining. Prototyping is created by additive process, which using a specialized software mimics a 3D CAD model. It constructs the part layer by layer until solid replica of the model is generated. It is used for various purposes, in our case, for surgical simulation and implant instrument designing. This is an example of rapid prototyping product. In this picture, it is fabricated femur model. CNC is a numerical control system in which the data handling, control sequence, and response to input is determined by an onboard computer system at the machine. This is the diagram of fixing system used in endoprosthesis manufacturing process. Hybrid CNC consists of 4 processes, which is processing head and neck, processing machine section, processing other parts. This is an example of hybrid CNC process structure. High precision machining is a process that draws a single hard pointed tool across a rotating surface in a highly controlled manner. This is an example of high precision machining product, which is doorknob. Thank you.
After we go through the screening and scoring process, we get that the best and suitable material for a surgical implant is titanium alloy. Titanium is stronger and lighter in weight compared to other material. Titanium also has a large tensile and compressive strength under repeated load stress, making titanium alloy capable of withstanding strain. Titanium also has a large resistance to load, making this material is best and suitable for its application as an implant material.